है ना, एक ही सीक्वेंस है. Then the sequence is said to be Cauchy if so I told you this definition, right? If given any epsilon positive, you have to find an integer k belongs to n such that this should be less than epsilon or all n m greater equals to k, right? So n epsilon positive. And what is the meaning of that? This, that for some k, the NMM should be greater equals to there, and all the elements of the event should eventually close to each other, right? After some n onwards, right? All the term of the sequence arbitrarily should eventually close to each other. This is the meaning of that. Is it clear?
Yes, sir.
So eventually all the terms should be close to each other. If that is the case, then the sequence should be Cauchy. So from here you have seen, and then also you have written, if you take this m, suppose n plus p or n equals to m plus p, right? Less than epsilon or all m greater than k, and p is some natural number. That is also you will put, if you put n equals to m plus p. This sequence is Cauchy or not? This sequence is Cauchy or not?
Yes, sir, Cauchy.
So how will prove this? I will prove.
Given epsilon positive, there exists k belongs to n.
That you have to see whether this k you will get or not, right? And from where you will get, the k? So we have to,
by Archimedean property.
Yes. So we have to see whether that exists k belongs to n. That you have to find. If you have to find a k such that this should be less than epsilon for all m greater equals to k. So you have to find a k. So does this k exist? And by Archimedean property confirms that the existence of k, right? Archimedean property confirms, because we have to prove this. So we know that this is the series of positive term. So, and from here you see only, so you have to write by triangle inequality, right? We are just written because these are all positive term, right? And this is lesser equals to 2 by a, right?
Yes,
and
sir.
so whether this should be less than epsilon, that means whether this is, so whether we'll get this kind of k or not, existence, whether k exists such that k satisfies this. Yes, Archimedean property will get one such k, right?
Yes, sir.
Is it clear? So is this Cauchy sequence?
Yes, sir.
No, is this one?
No, sir.
I'll prove. I will prove. So for this sequence, what will the maximum for this UN? So suppose this is UN sequence, huh? UN. So what will be the value of this mode? Maximum, minimum, what can be? What will be the value of this? Huh?
Maximum 2 or minimum 0.
Maximum 2.
Yes. Yes. So when both are odd or both are even, right? The value difference between 0 and one of them is odd, another of them even, the value is 2, right? So now you can see whether these values should be less than epsilon or not. Is this value will be always less than epsilon? The tail of the sequence. Eventually the terms are close to each other or not? Is it true? Because whatever epsilon you take for all natural number k equals to n, the tail of the sequence should never goes to 0, right? Difference between. You can see here. Earlier case you have seen, but here in this case, you will see the difference is supposed 2, right? But then if you choose epsilon equals to suppose half, is it true or not? So the definition should be un minus un should be less than epsilon for all nm greater equals to k. But you cannot find such a k because whatever nm you choose, ultimately this difference will be 2 you will get. If you get somewhere 0, next you will get 2, right? So 2 cannot be less than epsilon, right? So this is so this is so this is tell me, so this is a
Divergent,
no, in this case what we are proving?
not Cauchy.
Not
So
Cauchy
this
system.
is not a Cauchy. So that means if this is not a Cauchy, that means
This is divergent sequence
why? What is the property?
because this is
What is the
One is
property?
convergent and one is divergent.
No, means by which theorem we are saying that it is not convergent? By this property, right? So what do you a convergent sequence is Cauchy, right? That you have that you know, right? Already from the last class.
yes,
Is not
sir.
it? But I have written. Let me see. See, any convergence sequence is Cauchy, right? But for the converse, a Cauchy sequence of real number is convergent. So from this statement, any convergence sequence is Cauchy. That means what is suppose A implies B, okay? Then what is the contrapositive statement? Suppose A implies B. So this is your A statement, and this is your B statement. So A statement is that any convergence sequence. If it is convergence sequence, then it will be Cauchy. So Cauchy part is B. So if it is not Cauchy, that means so if it is not Cauchy, that means A implies B. But if B part does not hold, that means what should I obtain? If it is not Cauchy, then it is not convergent. Is it clear? That means negation of B implies negation of A. Is it clear? Is this statement clear to all of you? Is this statement clear to all of you? If someone is there who does not know this statement, quanta positive. So a convergent sequence is Cauchy. That means if it is not Cauchy, then it is not convergent. Okay. Is it clear?
Yes, sir.
So can you give some example of this statement? Can we, so is this clear, the statement? Huh?
No, sir.
No. Where is the difficulty? Where is the difficulty? That I want to know.
Sir, I can't remember Kochi, sir.
Huh?
I am unable to memorize Kochi.
Oh, wait for one. Hello.
Hello.
Hmm?
सर राहुल बात कर रहा हूँ मैं डिस्ट्रिक्ट से देख सकता हूँ
Huh?
सर राहुल बात कर रहा हूँ मैं डिस्ट्रिक्ट सर राहुल बात कर रहा हूँ मैं डिस्ट्रिक्ट से
कौन सा कंपनी?
माइंड डिजिटल कस्टमर एक्सपीरियंस कंपनी
कौन सा कंपनी? Hello. Hello, can you hear me?
Yes, sir.
So where is
Yes,
the
sir.
difficulty? Yeah, if you speak up, where is the difficulty?
Sir,
Huh.
I am not able to recognize.
So what do you mean by Cauchy sequence? That
Yes, sir.
eventually all the term of the sequence should be together. Okay. So that means this should be tends to 0, right? As n m both tends to infinity. This is the meaning, right, of that epsilon n. Is not it?
Yes,
Is
sir.
it clear?
Yes, sir. Yes.
But in this case, what is happening? Is in this case, is this happening? That if you take minus 1 to the power n, minus 1 to the power n, does this should goes to 0 as n m tends to infinity? What do you think? Does it goes to 0 as n m tends to infinity?
When both are even, or yes, sir, they goes to 0.
So here it is not like that both are even. This can be any integer. Tail of the sequence eventually should be close to each other. For all greater equals to 8. Does this happening here?
No, sir. For all number, there it is not.
So what this definition is for all, right? For all nm greater equals to k, this should be tends to 0. That means this difference should be less than arbitrary epsilon, right?
Yes, sir.
But this is not happening. If you take even for large n, take the next one as a your odd or even, then you will get 2. Difference is 2, right?
Yes, sir.
But 2 is not less than epsilon. Is not it?
Oh, sir. Then it is not the Kochi, sir.
So now it is clear or not?
Yes, sir. Yes.
So it is not Cauchy. Now I am saying if it is not Cauchy, if it is not Cauchy, then what will happen? Then it cannot be convergent. Is this statement clear?
Yes, sir.
Why?
Because a convergent sequence can be a Cauchy, and this is not
Can be
Cauchy.
nahi. A convergent sequence is Cauchy. That means if it is not Cauchy, it cannot be convergent. This is known as contrapositive statement. A implies B. That means negation of B implies negation of A. Okay.
Yes, sir.
So can you give some contrapositive statement example? Simple. That A implies B. That means negation of B implies negation of A. Can you give some example? If you cannot give now, you can check on your own later on. This is your homework to see. Because in mathematics, many times you will use this property contrapositive statement. Okay. Any other doubt? So a convergent sequence is Cauchy. And what about the converse? What about the converse? What about the converse? What about the converse? Converse that Cauchy can it will be converged or not? A convergent sequence is Cauchy. What about the converse?
So,
Yeah.
a Cauchy convergent.
A Cauchy sequence of real number. So generally this real number has complete that is actually used. That's why a Cauchy sequence of real number is convergent. So because you know the real number system has completeness property that you have seen already. So that will be used in the proof. Okay. So this is the converse that a real number is convergent, but a convergent sequence is all. And also you know the contrapositive statement. Okay. Suppose a square is rectangle. Okay. Its contrapositive statement. Square is a rectangle or not? Huh?
Not all rectangles are squares of the power. No rectangle to the purpose.
This simple statement you can see what is contrapositive. Okay. Any doubt? Any other doubt? In the last class, at the end, we are seeing series, right? And we have, you know, some basic series summation formula, right? What are they? Suppose UN is a sequence. Okay. Now we are defining sequence of partial sum. So this is U1, U2, plus UN. Okay. So this sequence of partial sum. Suppose the partial sum converges. Okay. Suppose this sequence of partial sum converges. Then what will happen for this series, this infinite series. So already you have studied sequence, right? Already studied sequence very whether it converge or not. Now, in the case of series, we are considering this series. Now to study convergence, divergence of this series, what we are constructing? First, constructing a sequence. What is the add sum from this series? Okay. Equals to 1 n ui. Is not it? Now we are checking whether this Sn, the sequence of partial sum of ui, whether this sequence is convergent or not. If this sequence is convergent, what will happen? If this sequence is convergent, that means this tends to infinity Sn. If this sequence, what will happen? What will happen if this sequence will converge? So this sequence is nothing but your partial sum ui, right? So if you see, what do you mean by limit tends to Sn? What do you mean by limit tends to What do you mean by limit tends to infinity Sn? Hmm? What do you mean by limit tends to infinity Sn? So what is your S1? What is your S1? Just U1. What is your S2? U1 plus U. Right? Sn U1 plus U2 plus. So now you are interested in seeing what about this sequence Sn? What is happening with the sequence Sn? Then if the sequence converges Sn, sequence converges, then what will happen with this series? This series is nothing but your what the sequence Sn converges, right? That will be your sum of this infinite series. Is it clear or not? Hmm? Is it clear or
Yes, sir.
not?
Yes, sir.
So what should I write? That un is, so un here summation means infinite series, huh? Is convergent or divergent if an right. So according to the Sn, right? According to the is convergent or divergent. Is it clear? Is it clear?
Yes, sir.
So, so can you let me see whether you know the sum example. This you I think you already know. Plus. Suppose calculate the sum of this series, right? So what we have
Sum of the sequence.
huh? What do you have to check? Corresponding
Whether the sequence is divergent or convergent.
corresponding sequence of partial sum, right?
Yes,
Is
sir.
not it? So what will be the sequence of partial sum? What is Sn here? What is Sn here? What is Sn here?
1 plus
The sequence
half
of
plus
partial sum of the series, huh? 1
1 plus half plus 1 plus half to power n.
plus our last term will be
1 divided by 2 raised to the power
1 divided by
1 divided by 2 raised to the power n minus n plus 1, sir.
n plus 1.
N minus 1, sir. N minus 1.
Because so this is summation of first n terms, right? So fourth term, in the fourth term, this is power is 3, right? In the second term, power is 2. So in the
Yes, sir. In the last term,
last term it
nth
will be
term.
n minus 1.
Yes, sir. Yes.
It's not it. Is it clear?
Yes, sir.
So what will be the your so what will be your summation then?
Sigma 1 by 2 to the power n minus 1.
Hello? So what will be the sum of this series? 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 So that you know, right? What will be the summation? This finite term. This already you have studied, right? What will be the summation?
Right, sir.
Sn. Then we will see where limit tends to infinity Sn will goes. So what will be Sn?
2, sir, 2.
No, not
A
2.
upon 1
We
minus
will
r.
see first the summation. Then we will see what is happening.
A upon 1 minus r.
What is happening with this one? We will see later. But what is A into?
A upon 1 minus r.
That
r
is
के power n minus 1.
So what will happening? That means 2 into 1.
1 minus r के power n.
Is this clear?
Yes, sir.
So ultimately you are getting 2 minus 1 by 2 to the power n minus 1, right?
Yes, sir.
Now limit tends to infinity, what will get? Now limit tends to infinity, 2.
2.
Because
Sir, 1 upon 2 के power n minus 1 equal to 0.
so how you will prove this? You have proved it, right? How you have proved it? 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 What will be what you have to use in proof? How will prove this one? If you studied now series, now you should not forget sequence, right? It will be used again and again, the sequence, all these properties, because sequence of partial sum Sn, what is happening with that? That the series property you will get in the beginning. Then we'll see the later on the all the test of the series. Similarly, whatever you have seen in the case of sequence. But how will get that this limit is 0? That you should tell me. How will get? Is this tough? How we will get this limit. What we have to use actually? What we have to use actually? Hmm? Next example. What we have to use actually? And this is nobody. How will get this one? Limitation 1 by 2 to the power n minus 1. That means limitation infinity 1 by 2 to the power n. This kind of sequence. I will prove that this goes to 0. What you at least one should who is there? Kotsami Latham?
The sequence of partial sum?
No. How will show their limit tends to infinity 1 by 2 to the power n minus 1 will be 0. This one. How will show? Because then we will see the limit tends to Sn equals to 2, right? So how will show this one? Nobody? This is the trivial example, right? Already you have done it. If you use this epsilon in definition, suppose, then you can use it. Or you can use various properties. And you can use in many ways epsilon and definition and all the properties, whatever you have seen in the case of sequence, right?
Sandwich also
Monotonicity
use
property,
the sandwich.
sandwich, monotonicity properties, the test, sequence test, various limitations to infinity, that your Sn here whatever you have, suppose this is your an sequence, okay? Now what is happening with this limit? In various way you can try. First one is epsilon n definition. By Archimedean property, you can prove it. Similarly, already you have seen in the last class, right? That this to the power m, this proof already you have seen, is not it? By Archimedean property, this kind of proof already you have seen in the last class. So monotonicity property you can also use. If it is monotonically decreasing and bounded below, then it will converge. That this n plus n or limit n or 1 by n. What is happening? You can try in various way, but at least in epsilon and definition that clearly whatever you have seen in the proof of 1 by n, similarly you can use just Archimedean property. You have to do it. That's it. It's not it. So what will be the okay? Let me see. What is convergent when this series your a plus a square when you are not studying, you know. In the last class also we have discussed little bit. This you have already studied in 12th, right? This series your convergent when model less than
Less than 1.
1, right? I will show it. I will show it. What will be your Sn? Sequence of partial sum of this series. What will be Sn? Tell me what 1 plus a plus a square. No. First I'll write. Last term will be
8 to the power of n minus
huh?
power n minus 1.
Yes. Correct. So what will be its summation?
1 into 1 minus 1 minus a power n upon 1 minus a.
1 minus a upon n into 1 minus a. Right. So that means you have got 1 by 1 minus a minus a to the power n by 1 minus a.
1 minus
Is not it? This you have got, right? So what
yes,
will
sir.
be the limit?
A
So this
tending
is
to
the,
tending to infinity.
this is given that mod a less than 1. Now we have to see what is happening with limit tends to infinity Sn, right? And what will be the value of limit tends to infinity n? What will be the value? This is given. Mod a less than 1 is
0,
given.
0, 0, 0.
0, right? That you have already proved.
Yes, sir.
Via which theorem you have proved?
And which theorem?
Yes. So you should not be confused, okay? With confidence, you should tell. By Sandwich theorem, you have already shown, right? And using binomial theorem, you have or not. You have
Yes,
shown
sir.
it or
Binomial
not?
theorem. Yes, sir.
Huh.
Yes, sir. Binomial theorems
So,
we get.
binomial theorem and Sandwich theorem together.
Sandwich theorem.
So, and already in the sequence property, if you know that if a sequence converges to some values, then if you if a scalar, then scalar and the sequence, see this one will converges to this sequence. Is not it that we have already started in sequence? Similarly,
Yes, sir. Yes.
that means the whole sequence here, limit tends to infinity, this value should be 0. That means the limit will be 1 by 1 minus a. Is not it? Is it clear? And this series is divergent when mod a greater equals to
Greater than
1.
1.
Yeah, that you can prove it or not. Already you have seen the proof. Already you have seen the proof or not?
Sir, if a mod a equals to 1, then it also equal to also is divergent.
Yes.
Sir,
Why
that
it
is a
will
constant.
diverge? Can you tell me? You are think that it will converge? So when model less than 1 in the series, either
It
a
is
plus
constant.
1, either a plus 1 or a minus 1, right? This you already have studied. So suppose plus 1 all are. So is this series convergent? Is this series convergent? Huh?
No, sir.
Suppose a minus 1. Then what is happening? Here 1
1
plus
minus
minus
1
1
minus
plus
1
minus
plus
1
1 minus
square.
1.
And what about this series? What
Yeah,
about this
then
series? Huh? What about this series? Is this series convergent?
No, sir.
Why? Because this already you can see, right? Because
the zero
It is constant.
you will get different type of values, right? You will not get a unique, right?
But, yes, sir. Either we get 1.
Yeah, even in the
Something else.
sequence of partial sum, you can okay. And later on we will also see different properties of the series test. Whatever you have studied for sequence test, similarly series test. There also you can see. So generally, if later on you will see that if a series of positive real numbers, suppose a convergent, then all its rearrangement of the series will also converge. Okay. Later on, we will see various kind of properties only for sequence series of positive real number. Okay. If the series is positive real number, then the series positive real number, in this case, some term is minus, right? All the negative. Then you will not get various properties. Okay. So till now any difficulty? Till now any difficulty? Till now any difficulty or not? You have any difficulty? Similarly, you can check with this also, this property also, for this series of, suppose un is your this series you want to check, right? So you are checking with the sequence of partial of corresponding of this series, and Sn is un plus into un. So now you have to check whether this sequence is convergent or not. This sequence Sn, the sequence of partial sum. So one already have definition. Here you can see that what similar. Suppose this sequence is convergent. You know that this series is convergent. From there, you will see that this value should be less than epsilon. Suppose this series okay, that means this sequence is convergent. And what do we mean by that? This sequence is convergent because convergent sequence is Cauchy, is not it? A convergent sequence is Cauchy. From that property, you can see that you can write always this property, right? For all n greater equals to k and p belongs to natural number n in p. This we will get. So this is true. This is the definition of Cauchy sequence. Is not it? And if you take p equals to 1, what will happening? That you get un plus 1 is less than epsilon. That means limit tends to infinity, un 0. Okay. Is this property clear? So here we have assumed that the series, then what is happening? The n term of that series should goes to 0 as entity. Okay. Implies B. So what is your A? What is your A here? That the series convergent. What is your B here? The limit tends to infinity un equals to 0. Is it okay? Is it okay? Suppose you will get some values such that limit tends to infinity un not equals to 0. Then what will happen? Is the property clear? That if the series convergent, then limit tends to infinity un equals to 0. Let me give one example. Is this series convergent or divergent? Is this series convergent or divergent?
Convergent.
Huh?
Convergent.
Is this series convergent or divergent?
Convergent, sir.
Convergent, sir.
No, this is divergent. I told you just we have to use this one. If the series convergent, then what will happen? Limit tends to infinity, un should goes to 0. Is not it? Then what do we mean by limit tends to infinity? Un by n plus 1. What will be the value?
One. One. Just
1.
limit will 10 to 1.
So does not goes to 0, right? So this is your necessary
Yes, sir.
condition. Okay. What do you mean by necessary condition? That if a series is convergent, then limit tends to infinity, un, then limit tends to un will be equals to 0, right? So that means negation of B should implies negation of A. I told you again and again. That means if limit tends to infinity even not equals to 0, what will happen? What will happen?
The divergent is.
So your contrapositive statement is clear or not? So this is only a necessary condition, okay? What do you mean by necessary condition? So if the series convergent, then only you will say. But you cannot say that if this is happening, whether this series will be, suppose this is happening, but we don't know what will happen for the series, okay? So we'll see, suppose this one. This series is convergent or divergent? This series is convergent or divergent?
Convergent because 10 is to 0.
No, again I told you, if the
Convergent.
series convergent, then only you will say, okay? That means if this is not equals to 0, then we will say this divergent. But if this is 0, we don't know. This is called necessary condition here. This is a necessary condition, okay? If the series convergent, then only the limit of your un will goes to 0. But if this limit is 0, we don't know about the sequence, okay? Is it clear? You can prove it,
Yes.
okay? So this is only a necessary condition, I told you, right? Is it clear? So if the series, if you know the series convergent, then we will say that limit tends to even is 0. But if the limit even equals to 0, we don't know. It may be or it will converge. Is it clear? But if this contrapositive statement that if this is not equals to 0, then we will say that the series is divergent. Till now, is it out? If you have any confusion, let me know. Maybe next class will continue tomorrow. Around at 2, right? We have class. Is it clear or you have any confusion? So, anyone? So, contrapositive statement is clear that A implies B. That means implies negation of B implies negation of A, right? So, what is A here? That n equals to 1 to infinity, un is convergent, right? What is B? The limit tends to infinity, un equals to 0. Is it clear or not?
Yes.
That means if limit tends to infinity, un not equals to 0, then what will happen? Divergent. But we don't know that if limit tends to 0,
or
may or may not. Okay, this is the property that if the sequence is if the series convergence, then n term of the series goes to 0. Of the series goes to 0, we cannot conclude. No conclusion. No conclusion about convergence of ठीक है.
Yes, sir.
So you have any class now, or you have any class now?
Yes, sir.
Okay, so we'll continue here next class. Okay, see you tomorrow.
Recording